Hello, am I audible? Am I
Yes,
audible?
sir.
Yes.
Yeah. Okay. So let us start. Today I'll show a small topic. Small but important. Right? So it's called different kinds of ordering on rooted trees. Okay. So let me share the screen. Can you see the screen?
Yes, sir.
Mm.
Okay. So here is the thing. The one thing that you need to know is what is called a subtree. Okay. So now by now all of you are familiar with rooted tree, right? A rooted tree is always drawn in this way. You know, the vertex right at the top, there is a unique vertex called the root. So in this case, this vertex A is the root, right? Another example is this one. In this drawing, C is the root, right? One vertex special, which is right at the top. Everything else is below that, right? So C is the root here. In this vertex labeled 7 is the root. Okay, so all of you are now clear with what is a rooted tree, right? A tree with a root. Yeah. Hello.
Yes, sir.
Yeah. Okay. So now here's the thing. There is a notion of left subtree and right subtree usually when you have a binary sort of rooted kind of trees. Okay, left, right, center, these kinds of things. Okay, so let's go here. So for this vertex, there are three children, right? 1, 2, 3, right? So this is the left subtree. All of this. You see, left child onwards, everything below. That is the left subtree. This is the right subtree. Just one vertex. The right subtree. Okay. And this is the middle subtree. Because it's the middle child. Similarly, if you go to the next vertex, next diagram, left subtree of C is this whole thing. Right subtree is this. Left subtree of A of this vertex is this much. Right subtree is this much. Okay. And now here, so for instance, left subtree of this vertex 3 is all of this. The right subtree is this. Okay, so there are some more examples. And you might want to look into those. Okay, there are many more examples that I've given, right? So that is it. Now let's go back to what is called sorting. So let me see if I can erase. Oh, I cannot. Then there's a problem. Mm, then this is not a good example. Okay. So we are only interested in trees which have left and right children, but not middle children. Okay, so this is a middle child. So I'll remove this. This one also has a middle child. So I'll remove this. Here we can manage this. Manage just manage this one. Okay, good enough. All right. So what do I want to say? So I want to introduce three ways of writing down the vertices of a binary tree. Binary tree is what you see here. Okay, every vertex has at most two children. You could have one child, could have two children. That's it. Okay, left and right. That's the maximum you will have. There is no middle child or anything. Okay, so for binary rooted binary trees, three different ways of ordering the vertices, putting an order to the vertices. Okay, so the first one is what I'll call the pre-order. Okay. What is the minimum? What is the meaning of pre-order? Pre-order works like this. You have to start with the root, right? Start with the root. Okay. There is a left subtree and there is a right subtree. Correct. Pre-order says write down the root first, then the vertices in the left subtree, then the vertices in the right subtree. I'll repeat again. Pre-order says write down the root first, then the vertices in the left subtree, then the vertices in the right subtree. But what do you mean by writing vertices of the subtree? Then you think of this as a subtree and again repeat. So for this, A is the root. For this subtree, A is the root. Again, you apply inductively the same preorder. You write the root, then the vertices of the left subtree, then the vertices of the right subtree. Okay, so in the pre-order sense, what will this be? First, the root. Okay, we have C. Okay. Then I'll just put this arrow to indicate the next element. Okay. After this, what is the left subtree? Left subtree starts from A onwards, right? This one. And then the right subtree. So let us complete the left subtree first. Now, if you think of the left subtree as a tree rooted at A, you have to write down the root first, right? So then you have to write down A first. Okay. Now, once again, look at this tree. In order to complete this, the root, then the left subtree, then the right subtree. So you have to go to the left subtree first. Again, here you have root, left subtree, right subtree, but these are only vertices, so it's clear now. Okay. So below A, the left subtree, you have clearly only vertices as choices, the root, left subtree, right subtree. So here at this level, in the left subtree of A, you have first the root B, its left subtree F, and its right subtree G. Alright. Now, what have we completed so far? We have completed the left subtree of A. So then we have already written A. So root is written, left subtree is written. Now the right subtree of A, which is D. Okay. Then what have we completed? We have completed the vertex A, the root A, the left subtree of A, right subtree of A. So we have completed this subtree. But this is the left subtree of C. Right? This is the left subtree of C. We have already written down C. C is written, left subtree of C is written, and now we have to write down the right subtree of C. Okay, which is E. Now, do you see all the vertices have appeared? A, B, C, D, E, F, G. Up to you all find all of them. A, B, C, D, E, F, G. Okay. So this is the ordering among the vertices of this binary tree, and it's called the pre-order. Okay. Is this clear to everyone? This much?
Yes, sir.
Yes, sir.
All right, good. Now notice this. What did we do? Root, left subtree, right subtree. That is the order, correct? Root, left subtree and right subtree, and then you induct on those subtrees. Okay. First the root, then the left subtree, then the right subtree. That is preorder. The next one is a similar thing but a variant where so in the previous slide itself let me write down this. So there is no color. Okay, anyways. Root and then three. Maybe I have to move these things. Is that okay? Root, left subtree, right subtree. Okay, and then this is for the above example. For above example, the pre-order is this. Is that clear?
Yes, sir.
All right. So now you have understood what I mean, right? When I write this, the root followed by everything in the left subtree, followed by everything in the right subtree. Within the subtrees, you will again induct. Okay. Now let me tell you the new thing. So the text box. What is a text box? Let's put that below. Let me give you a new order, which is called in order. What is the in order rule? Okay, in order. Now here's the pre-order means the root precedes everything else. Root comes first. In order means the root is in between the left subtree and the right subtree. Okay, so subtree, everything in the left subtree, followed by the root, followed by everything in the right subtree. Is that okay? So in this example, what will it become? Let's write it down. Okay, for will be what? So now note this. This is the root that you're starting with. This is the left subtree. This is the right subtree. The root, but you're not writing the root. You're going down to the left subtree first. Right? So the left subtree, root, right subtree. You're going to the left subtree first. Okay, so C is waiting for the left subtree to finish. So C is waiting. I go to the left subtree. Left subtree, the root is A. Now A is waiting. I go to its left subtree. Again, in this subtree, these are singletons, right? So this is the root, this is the left subtree, this is the right subtree, just one vertex each. So now in this left subtree, it's clear. So this will wait left subtree first, then the root, then the right subtree, okay, for this one. So in order, you will go below. The left subtree of A, which is B, F, G, there the root is B, left is F, right is G. So you first write F, which is the left, then root B, then the right, which is G. Okay, what does this complete? This completes the left subtree of A. Left subtree of A is complete. So now you can write A because this is in order. Now you will write A and then you will write the right subtree of A. Okay, So left subtree of A is complete. Now you write A. Now you write the right subtree of A, but right subtree of A is just one vertex. Okay. Now where are we? We have completed this, but this is the left subtree of C. Right? So we have completed the left subtree. Now we'll write the root, and then we'll write the right subtree, which is just one vertex. Okay. So over, now we'll write C, and then we'll write the right subtree, which is again a single vertex. So that is in order. Is that okay, everyone?
Yes, sir.
Okay. Third variant. Now, third variant is, you should be able to guess what the third variant is going to be. Okay. The third possible variant. This is called post. What is the rule? Post order says the root comes last. Left subtree. In the left subtree. Then everything in the right subtree. Is that okay? So now, can somebody tell me what the post order is going to be for this one?
F,
Easy.
G, then B.
Okay. No, no. So just be systematic. Tell me which root, which left tree, which right subtree. What is the root now? First step.
C,
Okay. Then you go to the left subtree. Okay. Then the root is.
A,
Okay. Then where do you go?
then B.
Left subtree of A. Its root is B. Okay. Then so you have this tree of singletons BFG. So there, what is the order? So what will the order be? Once you reach B, what is going to be the order?
F, G, then B.
Next, we have left subtree F, then the right subtree G, and then the root B. So what have we completed now? We have completed the left subtree of A, right? The left subtree of
Yes, sir.
A is complete. Okay. Then what will you do?
Then we need to complete subtree of C.
Right, right subtree of A. Hello. Hello. Why are you jumping? You have only completed this much. This is the root. There is a right subtree. There is a root. What do you go to C? It's not over yet.
Then from B to D, then to A.
You don't jump from B to D. Okay. Now right subtree of A, which is D.
Then
And you
A.
speak, be very clear so that you will not confuse yourself. Then
A.
A, the root of that subtree. Okay. Now what have you completed?
Subtree of C.
Which subtree?
Left subtree.
So you have to say that left subtree of C. So what next?
Then E and then C.
What is E?
E is the right subtree of C.
Okay. That
Then C.
C. C is the root of that tree. That's why you're writing C. Huh? You're simply saying F, G, D, B. That's not how you're supposed to say things. You're supposed to tell me what are you writing. Is it the left subtree or is it the root? What is going on? You understand?
Yes, sir.
Yeah. Okay. So everybody's clear with post order?
Yes, sir.
All right. So what are we
Yes.
going to do? We are going to do the same thing now. So forget the middle one. Let us give these examples some names. The middle one has a middle child, so that is not good. This is example A. Example B, middle is not important to us. Example C. Now note that whenever you have right edge here, it is the right child, okay? So there is no left child for such trees. That is okay. Chalega. But whenever you have a straight edge, straight below edge, you think of it as the left child. That is the convention. This is a left child. Is that clear? Perfectly clear to everyone.
Yes, sir.
Okay. So now, who is going to tell me all three orders for the first one? Supposed to be easy now. Okay. Pre-order. What is a pre-order rule? Root, left subtree, right subtree. Let's pick someone who wants to give me an answer. Sai, you want to try?
Yes, sir.
Yeah, pre-order for the first
So,
one.
सबसे पहले we'll take the root. So
Okay.
1.
Okay. So one.
There's no left subtree, so we'll
Yeah.
write 3.
Why is three? So we don't write anything.
Be-
Then we go to the right subtree. You understand? That's what I meant step by step.
Okay, okay,
So we don't write anything. Then we go to the right subtree.
okay. So it's 3.
Three, root of the right subtree. Okay. Then
Then 3's left subtree is 2, so we'll write 2.
very good. Okay.
Uh, then 4,
Correct. Then the root of the right subtree.
because yes, right subtree, and then 4's left subtree is 5, so we'll write 5.
Okay. Fine. Okay. Good.
सर मुझे एक डाउट है
बोलो.
सर ये हम लोग जो स्ट्रेट लाइन में उसको हम लेफ्ट सब ट्री क्यों बोल रहे हैं
कन्वेंशन. हम लोग सपोज करते हैं कि अगर स्ट्रेट लाइन दिखे तो हम उसको लेफ्ट मानेंगे. उसको बीच में नहीं
ओके
छोड़ सकते है ना, इसलिए एक तो लेफ्ट लेना है, नहीं तो राइट लेना है. हम मानेंगे कि वो लेफ्ट
ठीक है
है. That's what is called convention. We just fix it as a rule. Okay. So Sai, you have to complete. You have to give me all three.
Yes, sir.
Yeah. So in
So
order.
for in order,
So what is the rule for in
so
order? Can you tell?
left subtree, then
Mm-hmm.
root, then
Mm-hmm.
right subtree.
All right. Fine. So how do you do that?
So so we'll take 5 first.
Five. Wait. What are you doing? We are still in the first example,
Uh,
no? What is the root?
Root is 1.
What is the left subtree of one?
There's no left subtree.
So left subtree, root, right subtree, no? So what should I write first?
So 1 goes to
One.
3.
So five क्यों बोल दिया?
सर मैं नीचे से
नीचे
गलती
से
से
नहीं.
बोल दिया मैंने.
हाँ. Take your time, but be careful. Yeah. Now you go to the right subtree. Okay.
Which is 3.
But you don't write three, no? So you write three. What is the rule now for in order? You have to write the right subtree of one. But in doing the right subtree of one, you again have to use the same rule, no?
So then 2 will come.
Correct. Yeah. So 3 is the root of the subtree, and now again left subtree, root, right subtree. So you write 2 first. So that's the left subtree. Then the root is 3. Right? When you have the right subtree, now what will come?
So then 5 will come,
Right.
and then
4 is
4.
the root, 5 is the left subtree. So then 5, then the root 4. Okay. Now what is the post order? What is the rule for post order?
Left subtree, then right subtree, and then the root.
Okay, very good. So we'll start with which root? Which is the root you consider first? 1. Just go on saying what you're thinking, no? That will make it easier.
Do we have to start from the bottom for this one?
Why will you ever start from the bottom? Why are you ever going to start from the bottom? Did I ever start from the bottom? No. The
No,
tree
no,
I
no, sir.
consider is
I'll write.
always from the top. Why are you thinking about starting from bottom? There is no bottom, right?
Yes, sir. Yes,
Yeah.
sir.
Yeah. So
So
start
the
from the
root.
main tree. You always start from the main tree. There is no such thing as starting from bottom.
Okay.
Ah,
So
you
the
start with
root
the
is
main tree.
1.
Yeah. Arey yaar.
Root is 1. There's no left
Ah,
tree. So
okay. So what should I
3
write?
is the right.
Okay. 3 is the root of the right subtree. Then can I write something
Uh,
at this stage? No, right?
we'll write 2.
Why will I write 2? Oh, okay, sorry. Yeah. So, yeah, sorry. So I'll write 2. Okay, then,
Then 5.
yeah. So go on saying, what is 5? Why 5?
Uh, 2 is the left subtree of 3.
Uh-huh.
And 4 is the right subtree of 3.
4, 5
Uh,
is the right. Yeah.
when Yes, when 4 is the root, so 5 is the left subtree of 4. So that's why we'll write 5.
Okay. Then, is there a right subtree for 4?
So there's no right subtree
Okay.
for 4.
Therefore, we just write the root. So what does this complete? This completes the right subtree
Right subtree 3
of.
of 3.
Okay. So then what do we write?
So then we'll write 3.
Then we write 3. Right. Okay.
So this completes the right subtree of 1.
Okay. And then we write.
So then last we'll write 1.
So is this clear to everybody what is going on?
Yes, sir.
Okay.
Yes.
So next, who wants to try? Priya, you want to try? Example, oh, D is the same thing, but just the reverse. So take that as homework, okay? Just the labels have been changed, but the shape is the same. So example C. Priya, you want to try example C?
Yes, sir. First one is pre-order.
Wait. Okay. What is the rule for pre-order?
Left root, then left subtree, then right subtree.
Okay, very good. So sorry, this is for C. Go ahead.
Then 4 will come first because it's the root.
Where do we go?
Then
Left subtree of 4.
3.
Why is that? Because that's the root of the. Just give some explanation. Don't just say the number. Say something. It is the root of the left subtree of 4. Okay. Then left subtree of 3, right subtree of 3. What are those?
Subtree of 3 is 1.
Okay. Then
Then right subtree of 3, that is true.
Okay, so this completes what?
Left subtree of 4.
Okay, good. Okay. Then where do we go to? After that we'll go to,
Right subtree of 4, that is 5.
okay. Okay. You should be able to say this. Okay, otherwise it becomes difficult for somebody who is hearing to understand what is going on. You are not just telling this for yourself, not just telling this for me. The rest of the class is listening, right? You should
Yes,
be
sir.
able to explain things. This I'm not telling this to Priya. I'm telling to everyone. When I ask something, you should be able to give an explanation. Okay, so just keep that in mind. Right. So in order.
Rule for in order is left subtree,
Mhm.
then root, and then right subtree.
Okay. So how do I start? What is the root at this moment?
4 is the root.
Okay. So what will I? Where will I go? I'll go to the left subtree.
Yes, sir.
Then
First, we'll write 1 because it's the left subtree of 3.
three. Okay. So I'll write one. Then
Then we'll write the root
of that
3
subtree. Okay. So that's three.
of the
Okay.
sub. Then we'll write the right subtree of 3, that is 2.
Okay. This completes what?
This is how left subtree of 4 is completed.
Okay.
Then 4 is the root, so
Okay.
we'll write 4. And then we'll write the right subtree of 4, that is 5.
All right. Okay. Good. Now finally post
Third is post order.
order.
Rule for that is left subtree, then right subtree, and then root.
Okay. Good. Yeah. Go ahead.
Which will write 1 because it's the left subtree of 3.
Okay.
Then 2 because it's the right subtree of 3. Then we'll write
Three.
root, that is 3.
But this completes the
Then
left
4,
subtree of four.
uh, 4.
Then
There is no right subtree. So we'll write
there
4
is a right
as the
subtree. No,
root.
why is there no right subtree? This one, two,
क्या
three
sir?
completed. One, two, three completed the left subtree of which root?
4.
हाँ, so four के बाद four का right subtree है कि नहीं है?
नहीं है तो फिर we'll write the root.
अरे
That is 4.
four का right subtree नहीं है? ये क्या है?
अच्छा सॉरी सॉरी मैं वो डी देखने लगी थी सर.
अरे
सॉरी.
यार ऐसे नहीं करने का. नहीं 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 नहीं.
हाँ सॉरी सर. तो
हाँ,
5 आएगा फिर. It's the right subtree of 4.
right subtree of four. Okay. Then
Then we'll write the root. That is 4.
oh, okay. So A and C we have done, and D is now for all of you guys. Whoever you should try. Okay. So but you understand. D is exercise. Okay. B and D actually. So B is also exercise. Okay. Is that fine? So now let's
Yes
go
sir.
to another example. Okay. Slightly bigger example. Who wants to try? I don't want one person to give all three. I want one person to give one of them. Who wants to try? Voluntarily बोलो नहीं तो मैं उठाऊंगा. Neelam, you want to try?
Yes, sir.
Do you want to try? Haridilam, do you want to try?
No, sir.
No? Why? What happened?
सर मुझे क्लियरली समझा नहीं, मैं और एक बार देखूंगी.
अच्छा ठीक है, और एक बार देखेंगे आप. ओके. Anybody else? Okay, so what I'll do is I'll do all three orders once again so that I'm no, it's one more explanation. Okay, I'll repeat it for this example now. Okay. So let us begin with pre-order. Now pay careful attention to what I'm saying. Okay, I'm not going to use pointer because it just becomes I just want to see how much you're able to grasp. Okay, pay attention to what I'm saying and follow the numbers. Okay, so right. So pre-order. I'll start with the rule. So the rule is root left subtree right subtree. Okay. So first I have to write the root anyways. So the root is 1. Then I go to the left subtree. Left subtree of 1, its root is 2. Okay. So in that subtree, the root is 2. So I'll again write 2. Now I'll go to the left subtree of 2. In the left subtree of 2, the root is 4. So I'll write 4. Now I'll go to the left subtree of 4. In the left subtree of 4, there is only one vertex, so I'll just write that. Okay, that is the root itself. This completes the left subtree of 4. Now I go to the right subtree of 4. In right subtree of 4, there is again branching. So there is a root which is 9. And now I go to the left and right subtrees of 9. So the left subtree of 9 is just singleton 12. And then the right subtree is singleton 13. Okay, so maybe I should yeah, this is better. You're still able to read, no, even if the font size is small.
Yes, sir.
Okay, so I wrote 13. This completes the right subtree of 4. Okay, this completes the right subtree of 4. But 4 was the root of the left subtree of 2. And therefore now I go to the right subtree of 2. The right subtree of 2 has its root 5. So now I write 5. 5 has no left subtree, only the right subtree. So I just write 10. This completes the right subtree of 2. Okay, but 2 is the root of the left subtree of 1. So this completes the left subtree of 1. Now I go to the right subtree of 1. Again, the root is 3. I go to the left subtree of 3, which is singleton 6. Now I go to the right subtree of 3. Right subtree of 3, the root is 7. Then I go to the left subtree of 7, which is 11, which has root 11. It's a branching, root 11. Subtree of 11 is just singleton 14. There is no right subtree of 11. So this completes the left subtree of 7. This completes the left subtree of 7. Now there is no right subtree of 7. Okay, so the root, left subtree, right subtree part starting from 7 is complete. So this completes the right subtree of 3. But once that is done, root, left subtree, right subtree of 3 are complete. So this completes the right subtree of 1, which means the whole tree is over. And now if you check, there are 14 vertices total, 1 to 14, and you have 14 elements, all of them present here. Yep, there are total 14. So this completes the pre-order. Okay. Now let us do post-order. Sorry, in-order. How much time do we have? Yeah, we have time. Okay. In-order rule is left subtree, root, right subtree. First left subtree, then root, then right subtree. Right? Once again, we start with root 1, but we don't write 1 because we have to first go to the left subtree of 1. Its root is 2. We don't write 2, we go to the left subtree of 2, whose root is 4. We don't write 4, we go to the left subtree of 4, which is just 8. This completes the left subtree of 4. So now we write the root 4 and we go to the right subtree of 4. But right subtree of 4 has root 9 and it has a left and right subtree. So we have 9, its left subtree 12, then the root 9 and then the right subtree 13. Sorry. Okay. So 12, 9, 13. This completes the right subtree of 4 and 4 is the root. So that is complete. This completes the left subtree of 2. Left subtree of 2 is complete. So now we can write the root 2. Then we go to the right subtree of 2. In the right subtree of 2, there is only one root which is 5. Sorry, 5. Its left subtree is empty. So we don't write anything. Then we write the root 5 and then we go to the right subtree which is singleton 10. This completes, along with the root 2, this completes a left subtree of 1, of the root 1. And now we can write the root 1 itself. And now we go to the right subtree of 1. The right subtree of 1, root is 3. So we keep it there and we go to the left subtree of 3, which is just the vertex 6. So left subtree of 3 is complete. Then we write the root 3, then we go to the right subtree of 3. Right subtree of 3, root is 7. We keep it there, we go to the left subtree of 7. Left subtree of 7, root is 11. Its left subtree is 14. So we first write 14. Then the root there is 11. Its right subtree is empty. This completes the left subtree of 7. Then we write the root 7. Now the right subtree of 7 is empty. This completes the right subtree of 3. And this also completes the right subtree of 1. Therefore, we are done. Okay, all 14 elements are complete. That was the in order. So this is going into recording. So if you find that this is slow, you can always pause and think over it and do those things. Okay. So I'll continue straight away to the post order as well. Post order, the rule is left subtree, right subtree, and then the root. Root comes at the last all the time. For every subtree, root comes at the last. Left subtree, right subtree, root. So let's begin. Root is 1. We keep it there. We go to the left subtree. Root is 2. Keep it there. Go to the left subtree. Root is 4. Keep it there. Go to the left subtree. That is a singleton. Now the root is 4. We still keep it there. We go to the right subtree. Right subtree, root is 9. We go to the left subtree 12. Then the right subtree 13. And then the root 9. Because it's post order. This completes the right subtree of 4 and now we go to that root 4. This has completed, along with 4, this has completed the left subtree of 2. So now we go to the right subtree of 2. Right subtree of 2, root is 5, there is no left subtree, so we directly write the right subtree 10 and then we write the root 5. Okay. This completes the right subtree of 2 and now we can write the root 2. Once we write this, the left subtree of the top root, left subtree of 1 is complete. So now we go to the right subtree of 1. The root is still kept there. Right subtree of 1, root is 3. We keep it there. We go to the left subtree, which is singleton 6. Then we go to the right subtree of 3, which has root 7. We keep it there. It has a left subtree, which has root 11. We keep it there, which has a left subtree, which has singleton 14. But now 11 has no right subtree, empty. So then we only have the root 11. This completes the left subtree of 7. Then we go to the right subtree of 7, which is empty. So then we go ahead and write the root 7. This completes the right subtree of 3. And therefore we can now write the root 3. Along with 3, this has completed the right subtree of 1. So we have completed left subtree of 1, right subtree of 1, and now we can write the root 1. And now you can see that this covers all 14 elements. So this is the post order. All right. So I might have done this a little bit fast, so you can go back to this video and play this again and convince yourself that this is all okay. All right. But the general idea and the rules, is it clear to everybody?
Yes, sir.
Yeah. So
Yes, sir.
yeah. So pre-order is root, left subtree, right subtree. In order, left subtree, root, right subtree. Post order, left subtree, right subtree, root. Okay, that's how you're supposed to list them. All right. So finally, this is another exercise for you. Okay. So this is again another exercise. So order, in order, and post order. This is going to be longer. Right? Again, remember, whenever now you have to be a little bit careful. Okay. I said that by convention, if you have a single arrow, going down, then you will think of it as left. Okay. But now here there is already a left. Okay. Therefore, you will think of this as right. Is that okay? Again, here this has a right one, so it cannot be right. It is thought of as left. Okay. So the straight arrow here, depending on whether it has a left arrow or a right arrow, you have to make the correct choice for the direction, left or right. Is that much clear to everybody?
Sir, can you repeat this point again?
Yeah. So in this example, a single left straight arrow, right? There's no direction of left or right. So you will by default think of it as left. Okay, by convention. But in this example, you cannot think of this as left because this vertex already has a left arrow.
Yes, sir.
Therefore, this will automatically become right arrow. That's what I'm saying.
Okay, sir.
Okay. And similarly for this vertex, it has a right arrow clearly. Therefore, this automatically becomes a left arrow. Okay. So when you look at this diagram, depending on whether the vertex has a right arrow or a left arrow, the straight arrow will get its direction automatically. It's only when you have a single straight arrow. When you have a single straight arrow, that is when you need to make this choice. We will always choose it to be the left one. Is that clear, everybody?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So you have to complete this exercise. Check this once again, and these two exercises, B and D. B should be similar. D little bit more, but B is going to be easier. Okay. So that is it for today, and we are going to meet now on Monday, right? So today is Saturday. So we will meet on Monday at 8 o'clock in the morning. We are doing a bit of things. So I keep yourself free in the weekend. I will try to maybe give you related videos of this. Let us see. Okay, I'm going a little busy, so I'm not able to record, but I will try. I'm going to try to give you 1 or 2 videos in the weekend. Meanwhile, I have given you a few videos beforehand, so complete them if you have not seen them. And I have also asked you to read. If you notice WhatsApp, I have asked you to read a few things. Red black trees and this binary search. Okay, so read that. If you have not read it, read that, and I will post videos in the weekend related to that, the red black tree and binary search. Okay, and then we'll discuss that on Monday. Is that okay?
Sir, then notes of today.
Sorry, I you want me to share these? I'll convert this to PDF and post it.
Yes, sir, please share it.
Yeah. Okay. 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 So see you on Monday. Thanks.
Thank you, sir.